right now. So, welcome everybody, to be here with Dr. Lepeule, that she holds a researcher position at the National Institute of Health and Medical Research in France. She was formerly a postdoctoral fellow and visiting researcher at Harvard School of Public Health. So Dr. Lepeule research explores the influence of outdoor environment, especially temperature and air pollution, on health and the role of the epigenetic changes in such associations. A specific focus of her research is the influence of prenatal exposures on the health of the child in the context of Doha developmental origins of health and disease hypothesis. So we are very, very grateful and we appreciate that we accept our invitations and to be with us. Thank you very much, Dr. Johanna.
Okay, well, thank you very much, Erika. And I would like to first thank the organizers for having me today and for highlighting this topic of the impact of climate change on the health of the child. Thank you to the audience also for being here. So as said Erika, I'm a researcher at INSERM, which is the French National Institute for Health and Medical Research. And I'm located in Grenoble, France, in a team of environmental epidemiology and applied to the development and respiratory health. And I'm part of the steering committee of the French-speaking DOHAD Society. And my research aims at evaluating the effects of early exposure to air pollution, temperature, and vegetation on the health of the child. And I have a specific interest in the role of epigenetic marks. But today I will give you an overview of the research that is performed in the field of the effects of temperature during the developmental period, with a focus on the pregnancy for today's presentation, on the health of the child, what we know, what are the challenges, and how we tackle them in our work. So mainly in France and yeah. Up. So I have no conflict of interest to declare in line with the content of my presentation. So as you probably know, the impacts of climate change on health are manifold. Those impacts are more or less direct. And I will focus today on temperature, which has a direct effect on health. But there are also many other impacts, such as, for example, air pollution, which is a more indirect one, or water quality impacts and so on. So what do we know about temperature? So as you can see on this graph, the temperature anomalies worldwide are increasing since the 80s. So here the period of reference is 1950 to 1980, which is why we don't have many temperature anomalies in this graph. But since the 80s, we can see that the number of anomalies increase, and all of them are heat anomalies, and we keep breaking records almost every year. So Europe is the fastest warming region in the world. In France, as you can see here, the number of heat waves, as estimated by Meteo France, has been multiplied by 3 between 1947 to 1983, compared to 1984 to 2021. And here you have the number of heat alerts that are diffused by Santé Publique France, which is the National Agency for Public Health. And there is an increase in the frequency, in the duration, in the intensity, in the geographic coverage, and in the period within a season of the heat waves. So what do we know about the effects of let's say, an exposure to temperature with a high intensity and severity. So those are the numbers of deaths for Paris in 2000.
Sorry, can you hear Dr. Johanna?
No, I think we lost her.
No, we can't.
Okay. So
I will send her.
Okay, looks like I lost the connection. I'm back again. You still hear
thank you very
me?
much.
Yes.
Okay.
Nice.
That's good.
Yes.
So I was saying that there is no other event comparable to these heat waves in terms of exposure and in terms of health impacts. Okay.
I think your presentation is not being shared at the moment.
I'm not sharing?
No.
Okay, sorry.
No.
Let's see. Okay, so you should see my screen now. Okay.
Yes.
Okay.
Yes.
Okay, so yeah, that's fine. Okay.
Right.
So what happened with the milder exposure, meaning there is heat, but there is no specific heat wave, or it's not an extreme event. Heat can still kill people. So here again, I show an example for France, but there are tons of papers showing the effects of temperature on a regular basis with no specific heat wave on the mortality. Here, what we can see is that the effects of heat is starting later compared to the effects of cold, but the slope is steeper, which means there are going to be more deaths more rapidly. And the effect of cold is starting earlier across the percentile scale, but the slope of the slope is milder, so there are going to be less death. So having said this, we might wonder what are the effects on morbidity and whether there are populations that are more vulnerable than others. So the more intense and the more severe the heat becomes, and the more it affects the population, everybody will be affected. But some people are more vulnerable than others. Because, for example, of pre-existing diseases or other phenotypes, for example, related to age. Children and elderly are more at risk, pregnant women too. There could be other vulnerability factors associated with sex or with biological factors. Vulnerability could be associated with exposure because there are populations that are more exposed than others, which is the case of homeless people, outdoor workers, or people living in urban heat islands. And people are also more vulnerable depending on some socioeconomic characteristics. And so today I'm going to focus on pregnant women. So why are we interested in temperature during pregnancy? So I guess most people attending this seminar knows what is the DOHAD, but let's have a short reminder. So basically, the Dohad hypothesis state that environmental exposure to a very large extent during the developmental period and including the pregnancy could affect the health of the mother, but also the health of the fetus during the pregnancy, but also on the longer term, the health of the child and the adults, for example, affecting the development of the respiratory system, neuropsychological growth, and also associated with chronic metabolic diseases, cardiovascular diseases, and so on. So what do we know about the effect of temperature during pregnancy? So here I took some figures from a paper from 2022. So as you can see here, until 2015, there were not many publications in this field, and then it increased a lot. And if we would draw this figure again today, the curve would be even higher because this field of research has very much expanded. Which is a very good point. Most studies focus on preterm birth and low birth weight, which is still the case. And here, most studies are also conducted in high-income countries, in the US or China, and some in Europe. And this is very important that those type of studies could be conducted in many other countries because the effect of temperature can differ between different climate zones. For example, the thresholds in terms of vulnerability could be different depending on the climate because the population are acclimatized to the specific location where they live. In each country, there are also different demographic characteristics, different access to healthcare. So it is very important that those studies are conducted in different climate and in different countries to give the necessary results to inform public health policies. So these publications allowed recently to do some meta-analysis, and I quote some of them here. And here I extracted the results from one meta-analysis published in 2020 from Churzish and collaborators. So here they found an increased risk of preterm birth of 1.16 that was associated with being exposed to a heat wave during pregnancy. So here the heat wave was defined as 2 or more days with a temperature higher than a predefined threshold, which could be different depending on the studies included in the meta-analysis. And they also found an increased risk of preterm birth of 1.05 associated with a 1 degree increase in exposure during pregnancy. They also studied low birth weight and stillbirth and birth weight in terms of continuous outcome. And they also found increased risk of low birth weight stillbirth and a lower birth weight in average. So here, one of the limitations was that we don't really know what type of exposure the authors considered, whether it was an acute exposure a few days before delivery or whether it was a chronic exposure during pregnancy. All of them were kind of mixed in this meta-analysis. And the exposure assessment methods were quite raw. Most of them were relying on fixed monitoring station from the weather national system, which has limitation. I will talk about it a little bit later. So another interesting question, which I touched upon briefly earlier, is whether there are vulnerability criteria. So here is a study conducted in New South Wales in Australia, temperate regions. So what we can see first is that the author find a risk that is risk of preterm birth associated with a heat wave that is quite consistent with the meta-analysis of Churzish and collaborators. Here, this risk was identified for a cumulative effect of 7 days before delivery. So it's an quite acute exposure and effect. And also, interestingly, they investigated some vulnerability factors, and they show that there is an even higher risk of preterm birth associated with chronic illness during pregnancy, or diabetes, hypertension during pregnancy. So again, those results are quite important, especially for health professionals, to be informed and to be able to inform pregnant women about this increased risk regarding high temperature and preterm birth. And those results are quite consistent with other results that have been found in California, for example, and in other countries. So in the previous slide, I briefly talked about some of the challenges of the field, but there are many others that I listed here. So many of them relate to the way we estimate temperature exposure. There are many temperature metrics and many definitions. Some studies use a heat wave, some use percentiles, some use temperature minimum, maximum, minimum, average. And I didn't list all of them. But this is an issue in the sense that it is very difficult to synthesize the results, and there is no gold standard. There is also a lack of spatio-temporal resolution in the models that are used. And again, I will talk about this a little bit after in the next slide. Most studies are focused on heat, but it's also important to investigate the effect of cold, even if it's probably not the highest risk that we expect in the future. But some countries may be less prepared to face cold events in the future, so it's also important to investigate those effects. There might be some windows of susceptibility during pregnancy that are important to identify in terms of prevention, if we want to be able to get some prevention message to pregnant women. And for example, with preterm birth or stillbirth, most studies investigate acute effects, but it's also important to investigate effects that could occur or exposure occurring since conception, because they could also have an effect on those outcomes. Physiological acclimatization to temperature has been suggested in studies of mortality, but it hasn't been much investigated in pregnancy studies. There is also a synergistic effect with co-exposure, which could be the case for air pollution, and I will talk about it later with some illustration. Some of the effects might differ between male and female fetuses, because we know that boys and girls, for example, have different fetal growth patterns, and they have different levels of sensitivity to various prenatal stressors. And also postnatal effects on the development of the child are very rarely investigated. So as I said, exposure assessment is one of the main issues. So for example, as I said, most studies relied on weather monitoring stations or airport stations. So those stations are very useful because they have a high temporal resolution with hourly measurement usually. The issue is that the spatial coverage is quite poor, which could result in error in the exposure estimate and effect estimate that are biased towards the null, with less statistical power to capture these effects. Those type of exposure measurements do not allow to capture the urban heat islands, so meaning cities that are warmer than the surrounding areas, especially at night. And they are also, it's difficult to study rural population with such weather monitoring station because usually they are located in urban areas. If you can see here the map for Grenoble, for example, there are like 5 weather monitoring station here, which is really insufficient to represent all the contrasts in terms of temperature exposure within the city. So there are exposure models that have been developed. Some are physical models, numerical weather prediction. Those are very precise, but they are quite complex and costly to develop. And there are also statistical models that are incorporating, for example, satellite data. And this is what we have done in France. So others have also developed such models in Italy, for example, in Israel or in the US. So here it's a collaboration, a work that we've performed in collaboration with Ben Gurion University of the Negev, Itai Klug, in the context of the PhD of Ian Hoof. So basically we used surface temperature measurements from satellite data, meteorological station measurements, and many other spatiotemporal predictors, including, for example, vegetation, population density, altitude, and so on. And using different statistical methods, we were able to get some daily prediction of temperature, so minimum, maximum, and average temperature for almost 20 years at a spatial resolution of 1 kilometer for the whole French metropolitan area and 200 meters for large urban areas. And with very good performances, as you can see here. So really the advantages of this kind of model is that the error is low. It covers large areas and time periods. And you'll see later that it was very useful for us in France because it allowed us to pull some different cohorts and to get more statistical power to study the effect of temperature on pregnancy outcomes. It has a high spatial and temporal resolution, so it can identify urban heat island. Of course, there are some limitations, mainly due to cloudy days, because on those days we don't have satellite data or not of very high quality, but there are also other solutions to impute such data with a quite reasonable confidence. So we then used this fine spatiotemporally result exposure model to study the association with birth weight in France. So here, as I said, we pulled 2 cohort studies. So the mother-child cohort Eden, located in Nancy and Poitiers, and the Pélagie cohort located in Brittany. So we got a bit more than 4,000 births. And we investigated several metrics, so temperature average, minimum, maximum, and temperature variability. So interestingly, here we didn't see any effects of mean temperature, but we saw an effect of temperature variability. So here, using this fine exposure model, we were able to assess the exposure to temperature for each week of the pregnancy from conception till the end of pregnancy. And as you can see here, we found a negative association, meaning that when the variability of temperature was increasing between week 6 and week 20, it was associated with lower mean birth weight. And interestingly, when we stratified our analysis by sex, we saw that this association was mainly driven by boys, and there was not any association for girls. And in average, a 1 standard deviation increase in temperature variability between week 1 and week 21 of the pregnancy was associated with a lower birth weight of 125 grams in boys. So here this illustrates that other metrics might be useful than the average or the minimum and maximum. And these metrics might not be the same depending on the outcome we are working on. And this also illustrates that the effects of course, could be sex-specific. So after this, we said, okay, let's study then preterm birth. So we added one more cohort, which is located where I am, actually in Grenoble. So it's a smaller cohort. Here we had a total of 5,000 women and a little bit more than 200 preterm birth. So again, we studied temperature during each week of the pregnancy. So here we wanted to, so our hypothesis was that there may be some chronic effect, but there may be also some acute effect. So we studied the effect of temperature from conception till week 26. And also the temperature the 30 days before delivery. So in black, you have the average temperature, in orange, the maximum temperature, and in violet, in purple, the minimal temperature. So what we found here is an excess risk of preterm birth, so a risk ratio of 2, associated with an increased exposure between week 0 and week 5. During the pregnancy, and between week 20 and week 26, risk ratio of 2.9. So overall, we see the same trend, whatever the exposure metrics we take, but the effect is significant only for minimal temperature. So minimal temperature is usually taken as a proxy of night temperature, and the maximum is diurnal temperature, and the average is the average. Interestingly, here we didn't find any acute effect, while many other studies found some effects during the days before delivery. So this might be due because this might be due to the fact that we took also into account the chronic exposure, which is not the case of all the studies. So this was the effect of heat, and then we investigated cold. So for cold, we saw an excess risk of preterm birth of 1.3 when women were exposed to diurnal cold between week 6 and week 18 approximately. And an excess risk of 1.6 associated with cold exposure between days 4 before birth and day 10. So here we saw an effect of chronic and acute exposure. So those results are consistent with some studies that were performed in California and in Belgium. The fact that the association is clearest at night with nighttime heat echoes some results of mortality studies also, and this is important to know because the hypothesis is that hot days that are hot nights that follow hot days are particularly dangerous because they limit the ability to recover from daytime exposure. And interestingly, here we didn't see any association with temperature variability and nor with heat waves. So again, this brings the idea that temperature metrics might be different depending on the outcomes that we study. So I told you earlier that there were not much literature regarding the effect of temperature during pregnancy on the postnatal development. So I found one study on rapid infant weight gain. So here we decided to investigate lung function So we had some objective measurements of lung function at 2 months in the CEPAGE cohort only. So 6 parameters of lung function were measured: the minute ventilation, tidal volume, respiratory rate, time to peak, the lung clearance index, and the functional residual capacity. And here again, we studied boys and girls separately. So here are the results of girls. So this is a pretty dense slide. So we will go step by step. So here you have the exposure from week 1 of pregnancy until week 35. And then here it's the exposure during the postnatal period that we took also into account from week 1 to 4. And here we investigated also the possibility of an acute effect from the day of measurement of lung function until the 6 days before. We investigated the effect of cold in blue, heat in red. And again, nighttime temperature overall and daytime. And interestingly, what we found are very consistent results across the different parameters of lung function. So here it's the functional residual capacity, tidal volume, and respiratory rate. And we found a decreased functional residual capacity and tidal volume associated with cold exposure from quite early in pregnancy for a very long exposure window, and increased the respiratory rates also associated with cold exposure. And this exposure window was also active during the first week of life. But interestingly, we saw almost no acute effects. And regarding the effect of heat, again, on the same parameter, we found an effect of heat that were quite later compared to the effect of cold, but in the same direction with a decreased functional residual capacity and tidal volume and an increased respiratory rate. So those were the results for girls. And when we looked at boys, the results are quite different, as you can see. So even if there are some sporadic significant results, you can see that they are really, really less consistent compared to girls. So our interpretation was that there were almost no significant effect in boys, or at least there were really much more significant and present in girls compared to boys. So overall, there is, in terms of the mechanism, a lack of evidence on the pathophysiological mechanisms that could explain such association. Body temperature above 39 degrees could be teratogene for the fetus. This is quite well known. And then there are different hypotheses, but very few of them are evidenced in human population. So for example, there is the hypothesis that cardiovascular changes in pregnant women could explain such association with an increase in cardiac output, blood pressure, or viscosity. And there are a few studies on the effect of temperature, for example, on preeclampsia or blood pressure. Placenta could be also one of the responsible factors with reduced blood flow, which could increase the risk of fetal growth restriction and low birth weight. Some epigenetic changes may be at play too. We published a few years ago a paper showing some association between temperature and DNA methylation changes in the placenta. And there are also some other hypotheses regarding more acute effect that could trigger the birth. So this is a topic that we started investigating thanks to a new project that is funded by the French National Research Agency, where we are going to look at the effects of heat exposure during pregnancy on three main factors, so blood biomarkers, placental health, and cardiovascular health, with the idea that those changes could be the mediator of the effect that we see on pregnancy outcome or on the child neurodevelopment. And we're going to take also into account, of course, social and territorial inequalities. So another issue that I talked briefly earlier is the synergy between several exposure. So this is a topic that we are investigating with the French Agency for Public Health in France in the context of the PhD of Lucie Adélaïde. So the idea was to evaluate the effect of heat, air pollution, and vegetation together, because those three exposures are very intimately linked and have some shared physical and chemical mechanisms. So we studied cumulative exposure to heat, air pollutants, and vegetation at the neighborhood level. So here the scale is so each neighborhood is about 2,000 inhabitants. And we accounted for social deprivation. So the first aim that we had was to describe these three exposures separately over the years. For heat, we can, of course, see the year 2003, which was very particular, and here in red. But more interestingly, what we can see is that since 2015, the number of heat wave event and overexposure to high temperature is increasing with larger geographical coverage and occurrence every year, with again 2018 that is very high here in terms of exposure to heat. And I don't show the maps, but over the years, the exposure to air pollution was very reduced. This is a global trend that is seen in France, in Europe, and in many other countries. So then the second aim of this work was to identify hotspots. So hotspot for us was a cumulative exposure to overexposure to temperature, lack of vegetation, and overexposure to air pollution. And we study their association with social deprivation. So interestingly, what we saw is that the highest was the deprivation, the highest risk of being in a hotspot was associated in urban areas. In rural areas, the trends were a little bit different, with the people with the lowest deprivation or the highest deprivation being the more at risk of being in a hotspot. And overall, we also show that 4 million people live in environmental hotspot in average each year. So to conclude, we could say that there's been significant progress on heat and pregnancy outcome research in the past years, but there are still a number of limitations that remain. And in particular, we need more research, including both chronic and acute exposure, with longitudinal trajectory of exposure that are taken into account. More research on long-term outcome. As I said, we know pretty much nothing on the effect of on the postnatal effect of such exposure on the development of the child. We also need to have a better knowledge about the susceptible factor to be able to get some more targeted prevention message to the pregnant woman. Pathophysiological mechanisms are also very important to investigate because they are part of what's needed to have more evidence, to have more biological plausibility, and so to be able again to target more prevention, and also to know which are the protective or the adverse factors which could be at play. We also need to have more knowledge on fetal programming and potential intergenerational inheritance of such effects. So of course, adaptation, some measures of adaptation could be and should be performed to reduce vulnerability and increase protective factors. Because adaptation is not a cure, we also, of course, need mitigation and reduce the sources of climate change. So I'd like to finish with these slides, which highlights the opportunity of using health as leverage for taking action against climate change. So usually I like to show this graph because we very often talk about susceptibility windows and critical windows of exposure, but we could also see these windows as opportunity windows to improve prevention and make this risk of chronic disease trajectories a little bit lower to improve public health. And with climate change, this is the same reasoning could apply with many co-benefits that could be that we could have if we have early, and when I say early, I put some I'm not sure we are still early, but the earliest we take action against climate change, the more we will have some benefits. Thank you.
Thank you very much, Dr. Joanne. I think that your
Thank you
talk
very
is
much,
great.
Dr. Johanna.
Thank you.
Yep. We had a question from Paola. Eri, can you read the question, because I lost the connection for
Of
a
course.
moment and I lost the
Yes.
question too.
Okay, I'm going to read, but here is Paola. So if Paola want to make the question, or I read it, Paola.
Yeah,
Here's
can you hear me, Joanne?
Yes.
Can you hear me?
Yep.
Yeah. So I was wondering, in the chat, I wrote a question about the preconception, because if you consider couples in fertile time of the life, probably the most exposed population are the fertile couples who haven't conceived yet and are going to conceive in the next month, year, so on. So is there anybody looking at what's happening during the periconceptional period?
I've seen some studies. I'm not sure it was about the effect of temperature or air pollution, but yeah, I know that some research team are working on this. Actually, we are thinking about including also preconceptional exposure window, but it's something we haven't done yet.
Thank you, Dr. Johanna and Paola, for your question.
Okay. So I have a question. If you can hear me, I don't know if my connection is good now, but Dr. Johanna, it's interesting this dual effect that the heat waves have on the preterm birth that affects more in the first to 50 week and then to the 20 to the 26th week. Do you have any explanation for this? Considering the development, I don't know, maybe the brain development or the organs development is interesting because it's in the initial phase and then not in the last phase, but with 20 to 26 weeks.
Yeah.
Yes, in this graph.
Yeah. So actually, I don't have like for sure explanations, but uh, this is one study, so it has to be replicated in many other contexts and studies before being sure that those are the right vulnerability windows. But this is what's interesting with identifying those windows is that it could be useful for prevention, and it could be useful also for understanding what's happening in terms of mechanisms. Because if it happens early in pregnancy or later or in the middle of the pregnancy, this could suggest different physiopathological mechanisms. But for this one, I don't have like a strong explanation about why this is at those specific time windows.
Mm-hmm. Okay. Do you have any question from the public? No. So I'd like to raise a question because I live in Brazil and here we have the Amazon forest that is supported, including by the French government. We eventually see that Europe is supporting the protection of our forests. That includes Brazil, Colombia, and other countries here. And we have like a fight between the agribusiness that produces meat and the livestock and the people that wants to protect the forest. Now we have a really nice minister of environmental minister. It's Marina Silva, and she works hard for protect our forest like for the last 4 years, I think, or more. But we are all the time in this situation where we have the protectionists, the ONGs, and on the other side, the production of meat and the production of food, especially cereals and this kind of thing in Brazil. Uh, do you think we can like combine these two factors, like still produce but have a more protective environment? How your perspective of this, like living in France?
So I think we have this not the same fight, but kind of very similar issues in France and in Europe. Again, because some lobbyists want to protect their business, and others want to protect just life on Earth and health of the people. So this is a very broad question that you asked, but my feeling is that we need to change the way we live, and our societies need to move to a more resilient and sustainable way of life to be able to protect the vegetation and the health of the people.
In why you think that like the French government it's so sensitized for the environment protection? because we see that they are not only trying to protect the national environment, but also the world environment. So do you think that the researchers are have more pressure in the government in Europe maybe than here in the South America?
Ooh, I don't know actually. So I feel like you think that the French scientists have more power in France than in Europe, right? Honestly,
Maybe.
I don't know. I mean, to me, it feels like we are not the government are not listening enough to scientists in France and in Europe. But again, I don't have enough knowledge about how it is in Latin America or in Brazil to make some comparison.
Paola have a question, please go on.
Okay, I see that Paola is with her another question. Yes. Thank you.
Yeah, I was wondering, Johanna, how do you clean the effects, or how do you take out the effect of air conditioning? Because in most of Europe, in our country, which is not a extremely rich country, most people have air conditioner in their houses. So during summer, when you have over 30 degrees, people will have the air conditioner on. That in particular in our house, we put solar panels. So you can have the air conditioner on 24 hours without any problem because we have energy from the solar panels. So it's quite sustainable to have this kind of regulation of heat exposure in the population. Maybe not on the whole population, but an important amount of population in the work, in the public transport, everywhere we have air conditioner in the summer. So how do you clean for that? How do you get rid of that intervention? Let's say.
That's a very good question. Thank you. So for this specific study, we were lucky because this was between 2003 and 2006 in France. So France, by that time, was not a country with a high level of air conditioning. So here we didn't took into account the fact that a woman had air conditioning at home or not, or even at work, because honestly, it was really a minority. But in new studies and in the future, I bet this is going to be something we should take into account, right? So here, our hypothesis in this work was that ambient temperature, outdoor temperature, was going inside also, and there was no much difference. So in summer, it's not an issue. In winter, for cold, this is an issue because the temperature outside, of course, is not the same as inside. But when we're interested in the effect of heat, this is, I think, quite a reasonable approach.
Yes.
Maybe I'm not sure if you have considered this, but at some point you can take into account not only the environmental temperature, but also the body temperature that you can get from the watches. The watches give you can export the data to some studies are already doing that. They could set they take the information from the watch, and then you can know how many hours the people sleep, what's the heart frequency, the body temperature, etc. So maybe you can use this information in your population. Have you considered, is it possible to do that in your studies? So because one thing is having air conditioner, and the other, especially because the effects you see are in the night, high temperature during the night. So your sleep isn't good enough because of heat. So
Right.
it would be nice to have body temperature, because if it's hot, then your body is not comfortable because it's. Is it possible that you use this kind of data in the population?
Yeah, I think it's possible. So in our new, I mean not new, but in the cepage cohort, which is the youngest, so our participants have connected captors and miniaturized captors. So they have personal capture of temperature and air pollution and so on. So this is something that we are going to be able to explore. But actually, regarding the body temperature on the skin, I'm not sure how variable this is compared to ambient temperature. I mean, I guess if your thermoregulatory mechanisms work well, then your body temperature should stay stable. So I don't know actually how valuable and how useful it could be.
If it's in the skin, probably it can be more useful, but if it's in the internal temperature, probably it's going to be very physiologic, very stable.
Okay. Yeah,
But
right.
maybe in the skin, it could be a little
Yeah.
bit better because you're losing heat or trying to keep heat in the case of the cold. Yeah.
Yeah.
Or maybe sensors in the houses. We did a study where we put sensors in the houses for intra-house contaminants. And you can also put sensor for temperature, the houses. Yeah.
Yeah, actually we have sensors that we ask participants to carry with them for a week. And we know also when they are inside or when they are outside. But still, this is a constraint because they have to carry with them. So a watch would be probably more relevant, right? And easier to accept for the participants.
Johanna,
Yeah,
yes, it's really a very nice conference.
thank you.
Especially if we take into account increasing the number of preterm births in the world in the last years, no? But what kind of preterm infants we are talking about? Late preterm, very low birth weight, and this difference in the number of preterm births has changed the incidence of neonatal mortality and comorbidities in the short term.
So here, in this study, it's mainly late preterm. Yeah, right. But it's only preterm. We don't mix preterm and low birth weight, for example. I mean, some preterm might be also low birth weight, but here the outcome that we studied was really preterm birth.
Okay.
Does it answer your question?
Yes, yes. So is it late preterm is preferable the population that you have seen?
Yeah, we might have a few, very preterm, but this is really not the highest proportion of our preterm birth because the population is really general population. So
Okay. Yes, yes. Thank you very much.
So we are reaching the end of our webinar. We have only one more question here from Carlos Grandi. Do you know any experimental model in animals with heat waves, something like this? If you can comment some.
experimental. There are studies in animal looking at the effect of heat. There are a few paper. I remember. I don't have all of them in the top of my head, but I think we quoted them in our paper. There is at least one that I remember, which is Wells, WELLS, which is, I think, a review about the effect of heat on gestational pregnancy outcomes, including animal studies. And for the others, I don't have them in the top of my head. Sorry, but they are
No,
probably
okay.
quoted in our publication. Yeah. This is there are not like tons of
Okay, so
studies, but there are some.
mhm. Okay, thank you very much. We can find it in Sancho Carlos later. Okay, Carlos?
Yeah.
So thank you very much, Dr. Johanna. It was a pleasure
Thank
to have
you.
you here
Thank you
today
for the
and
invitation.
showing these concerning results, in fact, because here in the South America, we are now facing like inundations in the south, and Mexico is in a big heat wave. There's some animals is suffering a lot, humans of course too, but I think that animals suffer more, especially near the cities where they lost their wild environment. So all the results you bring to us today is really concerning, that we are living the outcomes in fact
Mm.
lively now. So thank you very much for your presentation, your
Thank you very
data,
much
and
for
we
the
hope to
invitation.
follow you.
And I hope it's gonna be everything is gonna be all right for you. And yeah, thank you.
We hope to see you in the 2025
Thank-
World Congress, Doha World Congress in Buenos Aires. There's going to be a big topic on
Yep.
One Health,
Yeah,
environmental exposures and so on.
yeah.
So you're very welcome to visit September 2025.
Okay. Thank you
Yeah,
very
we are
much.
presenting the some of these aspects to Dr. Joanna in the start before start. Bye bye. Have a great day, big people.
Thank you. Bye bye.
Thank you. Bye.